Hello everyone, welcome to the next lecture on the optimization techniques. Today I will explain you how you can solve the LPP with the help of Simplex method. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the optimization techniques, and you can see the previous lecture is on the Simplex method and many more lecture available in this playlist related to the complete optimization technique. You can subscribe my YouTube channel so that when I upload my next video, you will get the notification. Now, whenever we are working on the simplex method, that means our target is to solve the linear programming problem. And we all knows whenever you have a two variables like x1 and x2, you can easily solve this problem with the help of the graphical methods. And I'm very sure your reaction will be look like say this when you solve the problem with the help of graphical method. However, whenever there is more than two number of the variables like x1, x2, x3, or whenever there are more than the two constraints, then it is difficult to solve the problem with the help of graphical method. Then in order to address this problem, the method simplex is used for solving the linear programming problem. First of all, what is the goal of the simplex method is? That means our target is to find the optimal solution from the feasibility. That means the simplex method is applicable only, this is applicable only when you have a feasible solution. And how you can check about the feasibility? You can always see whether this right hand side, whenever the right hand side is my positive, you can assume that a feasibility achieved. Now, for example, in this case, you can see all these right hand sides are my positive. So I can say this solution, it has a feasible solution. Then your target is to find the optimal solution. Simplex method was firstly proposed by Garg in the 1946, and he is the person who are born in the 1914 and died in the 2005. This method is basically used for solving the linear programming problems whenever your feasible region is my convex. How you can check about the convex feasible region? I suggested you can watch about my this lecture on the convex set and the feasible region. Again, this method is working towards the movement of the solutions around the corner points of the feasible region. Now, most important thing is the simplex method is of the two category. The type 1 when all those constraints are my less than equal to sign, while the type 2 is when at least one constraint is greater than or is equal to sign. Whenever all those constraints are less than equal to sign, then we always apply the simplex method, while whenever this condition will satisfied, we can apply either the big M method or two-phase method. The process is simple in the both the cases. What are the steps we can follow? Whenever you have the linear programming problem, always write in terms of maximization. For example, if you have the objective function 3x1 minus 2x2 plus 4x3, try to convert this optimization problem into the maximization of z. How you can convert the minimization to the maximization? I can multiply this by the negative sign. So it's a minus minus plus and it's a minus of 4x3. So our target is to apply the simplex method on the maximization problem. It is not compulsory that you can always apply for the maximization. You may apply for the minimization as well. But the better is you can apply for the maximization so that your rules and the steps that we are followed is uniform for the each problem. So our target is to check all these 5 points. I'm not explaining all these points right now. I will explain you with the help of the numerical example. The first step is the most crucial one. That is how you can write the standard form. For more detail about the standard form, you can watch about my this lectures. That means the right hand side must be positive. All the constraints are of equality form. You can apply the slack or surplus variables, and all the constraints are all the decision variables are my greater than equal to form. Now I hope you can like and subscribe my YouTube channel as well. So I will explain you this process with the help of the 5 to 6 numerical examples. Dear student, I hope you can like and subscribe my YouTube channel to support my efforts. Now solve the problem by the simplex method. You can see all those constants are my less than sign. So that means you can apply the simplex method. Moreover, you can easily solve this problem with the help of the graphical method as well. Why? Because it has a two variable. You can easily draw the graph. This is the first line, fine, and it will be, this is 8 by 3 and this is 4, and you can easily draw the second line. So you can find the corner points and find the feasible region. Now I will apply the same problem on the simplex method. So your first step is you can write in the standard form, because this is already maximization. So I can write the standard form is maximization of z 4x1 3x2. Now because the constants are not equality, so I can change into the equality by adding the slack variable. I can say 2x1 3x2 plus s1 is 8. Similarly for the second constant, 3x1 plus 2x2 plus s2 is equal to 12. While all those variables x1, x2, s1, s2 are my greater than equal to 0. Once you are writing this standard form, then what is your target in the simplex method? How many variables you have? There are the 4 variables. I can write the table. This is my x1, this is my x2, this is my s1, this is my s2. Fine. How many constants are there? There are the 2 constants. So I can write the 2 rows, 1 and 2. So your target, what is your target? Your target is to fill all these values. Fine. And I will tell you in this lecture a very simple way or shortcut tricks how you can fill these entries in the 15-second time periods. So you must watch this video till the end. So first of all, you can write the coefficient of the x 2, coefficient of the x 3, coefficient of the x2 3, coefficient of x2 2, coefficient of the s1 1. There is no coefficient, so it's a 0. Similarly, coefficient of the s2 in the first constant 0, coefficient is my 1. Solution means that is the right hand side. Right hand side is my 8 and this is my 12. Fine. Now, once you have entered all those values, look at these values. Look at this value and try to find the identity element. Try to find the identity matrix and their elements. So can you find the identity matrix? So there are the 2 constants. So you can see this is my identity matrix. Fine. And we all knows the identity matrix is the first column is 1 0. What is the first column is? This one. And the corresponding column is my S1. So you can write the first value is my S1. 0 1. 0 1 is my S2. Make sure student you have to write this column according to the identity matrix. Fine. Now the last step is you have to find the value of the Zj minus Cj. What is the value of the Z? Coefficient of the x is 4. Coefficient of the x2 is 3. There is no S1, there is no S2. So then what is the coefficient of the S1? 0. S2 is my 0. These are the 2 values. How you can find this Zj minus Cj? Multiply this number. I can find how you can find this number. 0 multiply 2 plus 0 multiply 3. This is the value of the Zj minus C. This is the value of the C minus 4. So this answer is my minus 4. Similarly for this number, 0 multiply 3 plus 0 multiply 2 minus upper number. So that will be my minus 3. Similarly for this part is a 0 minus 0, 0 minus 0. There is no solution, so you can simply multiply and get the number as 0. Fine. Now that is the step number 1. Then your target is to find the entering variable. Look at all those values in the column Zj minus Cj which has the value less than 0, strictly less than 0. I have these 2 values. Fine. And then look at the value which is largest in the magnitude, which is largest in magnitude. Only in those values which has zj minus cj less than 0. So I can say, what is that? This is minus 4, and this variable is called as entering variable. This x1 is called as entering variable. Fine. Once you will find all those values of the zj minus cj row, find the largest in the magnitude, that's a minus 4. So this variable x1 is my entering variable, and this column is called as pivot column. Fine. Now once you enter this variable, this is my entering variable, then you have to find the ratio, that is called as the minimum ratio. What is the formula for the minimum ratio? Is that is my solution, that is the right hand side, divided by the pivot column, and we all know this is the pivot column. Fine. You have to take the ratio 8 divided by 2, 4, 12 divided by 3, 4. But make sure once you have taken the ratio, consider only those values, which are my positive. Fine. What is the meaning of this positive? Is if I say this number is my negative, for example, then you are unable to compute this ratio. You consider only those value in which the pivot column is my positive. Fine. Now if I again find for the minimum ratio, what is the minimum ratio? Is 8 divided by 2, 4, 12 divided by 4 is. So now look at the minimum value. In this case both are same, so you can choose any of the value as the leaving variable. So I can choose this number. So that means this column is called as the pivot row, and this corresponding variable is called as leaving variable. That means in the next table I have to, and the common element is, this is my pivot column and this is my common element, and this element is called as pivot key element. Once you find the pivot key element, then again your target is to write the new table zj minus cj. This is the leaving variables. I can replace this leaving variables, and the entering variable is my x1. Fine. I can leave the variable x2 and enter as the x1. Fine. Now your target is to write the values. Now I will tell you the shortcut tricks how you can write the values. First of all, this is always be the identity matrix. So since there are the two variable, identity matrix is 1 0. So first column is my s1, so you can write the first column is 1 0. Second column is my x1, so you can write as the second column x1. Fine. And once you write this is the identity matrix, zj minus cj is always 0. Always remember, zj minus cj is 0 always for the column corresponding to the identity matrix. Fine. So your target is to write this. Now your target is to find all these remaining. So what is the box element? Is 3. You can divide this complete row by 3. Divided this complete row by the box element. So that is 2 over 3, 0 by 3, 1 over 3, 12 upon 3. Fine. Now I will tell you the two different method how you can find the elements value. So firstly I will tell you the long method, and then I will tell you the shortcut tricks. You can see this is my 1. Your target is to make this number is my 0. So that means I can multiply the row of the x1 by 2. I can multiply this row by 2 and subtract from the s1. Fine. That is a 2 minus 2, 0. Similarly, it's a 3 minus, I can multiply this by 2. So 4 upon 3. So that is 9 minus 4, 5 over 3. So this number is my 5 over 3, and so on. Fine. But that is a quite lengthy procedure. Or you can say this is my say R1. This is R1. This is R2. So how you can make this? I can use the operation R1 minus twice of R2. R1 minus twice of R2. But I will tell you the shortcut tricks. Fine. Listen very carefully the shortcut tricks. I can write this number is divided by 3. Now, how you can fill this entry within the 5 second? Fine. The shortcut tricks is you have to find the determinant divided by the box element. Fine. Now, for example, I just want to write this value. What is the previous value? Previous value is my, sorry, this number is 0. So previous value is my 0. Fine. You always pick the 4 numbers. You always pick the 4 number. One element is my this. Other element is my box element. And the remaining 2 element in such a way that it will form a box. Like if you take 3, if you take 1, if you take 0, if you take -4, and you can see this will form a box. Fine. But remember, box can never be look like this. Box is always be the 4-sided. Now, so what are the 4 values? So I can see, I can write for you here. The 4 elements are my, so these 4 elements are, I can write these 4 elements, -4, 3, other previous number is 0, this number is my 1, and my box element is 3. Now you can find the determinant. How you can find the determinant of A, B, C, D? We all know this is AD minus BC. Fine. But always whenever you start from the box element. Fine. So the box element will be 3 into 0 is 0 minus the sign opposite of this. So minus minus plus 1. Always remember the rule is the determinant, but start from the box element divided by the 3. So this element number is my 4/3. Fine. Look at this, the one. You can see for the other one. Say for example, you want to calculate this number. What is the previous number is? Corresponding to S1 is 3. Fine. Which 4 number you can taken? These 4 numbers you can taken. So find the determinant, start from the box element. So this will be 9 minus 4 divided by the box element. Box element is my 3. So this number is my 5/3. Similarly, if you want to calculate this number, what is the previous position is? 0. Fine. So what are the other elements? What are the other elements? This is a 0. This is 3. Other number is 12. And this is my -4. So you can start from -4. This is the box element 3. This is 0. This is 12. Start from the box element. So that will be 0 minus minus plus divided by the box element. So that will be my 60. Fine. Now I can complete this table. So this last row is with my divided by the box element. Now can you find this element quickly? Previous value is -3. One is a box. Other is -4 and 2. So it's a -9 plus 8 divided by 3. So it's -1/3. Can you find this number? 9 minus 4, 5/3. Can you find this number? 3, 0, 1, -4. So 3 into 0 is 0 plus 4 divided by box element. Can you find this number? Previous number is my 0, then 1, then 3, and then 2. Start from the box, 0, then it's a -2 divided by 3. Can you find the last number? What is the previous number is? Previous number is my 8, one is the 3, one is the 2, and second is the 12. So 8 into 3 is 24 minus 24 divided by the box element is my 0. And you can see this value I have computed this method. Fine. Again, you can see whether, look at all those values in which Zj minus Cj is less than 0. So we have the only one value. So that means this is my entering variable. Fine. This is my entering variable. And what is the leaving variable? You can find the ratio. Fine. So that is a box element divided by the positive term. So that's a 0. 4 divided by 2/3. 4 divided by 2/3, 6. So the minimum element is my 0. So this element is my box element. Fine. So next table is I can construct Zj minus Cj row. This is my leaving variable. this is my x2 is the entering variable. So I can write this is my x2, this is my x1. Fine. Now again, your target is to write this is the identity matrix. This is the first column. X1 is the second column. So this is my, and this element is my 0, 0. Fine. I can divide it, this complete row by the box elements. So this number will be my 3/5. This element, if you divide them, it's a minus 2/5. This element is my 0. Now rest of them you can find it by the box rule. So you can see if I want to find this position, 16, 5/3, minus 1/3, 0. So start from the box element. So 16 into 5, 80/3, minus plus 0 divided by the box element, 5/3. So that number is my 16. You can find this number. Previous number is my 0. This is 1. This is 5/3. This is minus 1/3. So this part is my 0. This is plus 1/3 divided by the box element, 5/3. So the element is 1/5. You can find this number. Previous number is my 0. The rest two elements are my this. So you can start from the box element. 0 is a minus 2/3 divided by box element. So the answer is minus 2/5. Similarly, you can find the other number. Like say I can find quickly for you the last value of this. 4, 2/3, 5/3, 0. So the answer is 20 minus 3, 20/3 minus 0 divided by 5/3. So the element is 4. Similarly, you can find these two elements, and after finding you will get the answer as 6/5, 3/5. Now again you can find the values Zj minus Cj which is less than 0, and you can see in this column there is no value which is less than 0. That means the optimal solution achieved. And how you can find the optimal solution? The value of the x1 is 4. x1 is 4. The value of the x2 is, the right hand side value is my 0, and the value of the z is my 16 is the right answer. So my problem is solved with the help of the simplex method. Always remember, you can apply this trick to compute the value quickly. Now let's start with the another example. I hope student you can like and comment on the video. Solve the following problems by the simplex method. All those constants are less than sign. So that means this is simplex method. I can write in the standard form. I can write this is the slack variable s1, s2 and s3. Then my target is to write how many variables you have. x1, x2, x3, s1, s2, s3. You have the 6 variables. So my target is to complete this table. Can you write the coefficient of the x1? 1. Coefficient of the x3, this is 1. Coefficient of the x2, 2. This is 0. This is 4. Coefficient of the x3 in the first constant, 1. This is my 2. This is 0. Similarly, this is 1, 0, 0 and so on. Can you find the identity elements? This is my identity elements. Fine. And so the first column is my 1, 0, 0. This is S1. Second column is 0, 1, 0, which is corresponding to the S2. And the third column is S3. Fine. And what is the objective function is maximization. X1 is my 3. So I can say this is 3. This is my 2. X3 is my 5. And the rest values are my 0. Now can you find this Zj minus Cj? The value of the S1 is 0. S2 is 0. S3 0. Multiply, how you can find this number is 0 multiply 1. 0 multiply 3. 0 multiply 1 plus 0 multiply 1 minus upper value. Upper value is my 3. So the answer is minus 3. Similarly for the second one, it's a minus of 2. This is minus 5. These values are my 0. Fine. Now your target is to find all those values which has less than 0. So I have these 3 values. Look at the value which is largest in magnitude. So which one is the largest in magnitude? So minus 5 is my entering variable. Fine. So once you can write this is the entering variable, Find the minimum ratio. Find the minimum ratio. Taken only those values which are my positive. So 430 divided by 1, 430. 460 divided by 2 is a 230. Because it's a 0, so you can skip them. Only taken the values which is my positive, which is the minimum. This number is my minimum. So the common element is my 2 is my box element. That means x3 is my entering variable, and which one is the leaving is s2 is my leaving variable. So in the next table I can remove this value s2, I can add as the x3. Then again, because there are the three constants, the first column of the identity matrix is 1 0 0, that is s1 1 0 0. Second column is 0 1 0, which is x3 0 1 0. Third column is my 0 0 1, which is corresponding to the s3. Fine. And the value corresponding to the zj minus cj is always 0. Fine. And lastly, you can divide this row by the box element. So this part is my 3 over 2, 0, 0, 1 over 2, 0, and 230. Fine. Now rest of the value you can easily compute. For example, you want to compute this number. Previous number is my minus 3. 1 is a box element, minus 5 and 3. Start from this 2 box elements. So it's a minus 6. Change the sign, plus 15 divided by the box element. So that will be my 9 divided by 2. Fine. You can see 4.5. Similarly, I can find this number. Previous value is my, you can see here, previous value is my 1, 2, then this one and this 3. So start from the box elements, say 2 minus 3 divided by the box elements. So this number is my minus half. Can you find this number? Previous number is my 1. 1 is the box element, 0 and 3. So start from the box, 2 minus 0. 2 minus 0 divided by 2, that is 1. Can you find this number? Previous number is my minus of 2. Then 2 minus 5, 0. Start from the box element. So this is my minus 4. Minus minus plus 0 divided by the box element, minus of 2. Similarly, you can find this position. Previous value is my 2, then 1, then 2, 0. Start from the box element, 4 minus 0. 4 minus 0 is 4 divided by 2. Similarly, you can find this position. It is my 8 divided by 2 is 4. Similarly, you can find these all other elements and you will get these all numbers. Now again, you can check about zj minus cj. Is there any number negative? So since there is only one negative number, you can find this is my entering variable. Find the ratio. So this number is my positive, so it is my 1 0 0. This is my 0, so you can skip that. It is my 1 0 5. So which one is the minimum? 100 is my minimum. So the box element is my 2, leaving variable is my s1. So I can leave this variable as a x1, entering as my x2. Fine. Now again, you can write the identity matrix. This is the first column. It is my x2, 1 0 0. Second column, x3, 0 1 0. Third column, x3. Fine. And the values corresponding to them is always 0. Divide this row by the box element. So this number is my minus. I can say it's a 1 over 4. 0 is a 1 over 2. It's minus half. I can say it's a minus 1 by 4. It is my 100. Or you can say it's a minus 0.25. Fine. Now again, can you find this previous number? Previous value is my this. Can you take the 4 numbers? Fine. This is my 9. You can say 9 minus minus plus and then again minus. It's a 1 divided by the box elements. So 8 minus 1, 4. Can you find this number? Previous value is my 3 by 2. So you can take the 4 values. What are the 4 values? Previous number is my this. Then one is a box element. Other two are my, start from the box element. This is my 3. minus 0 divided by the box element. So this is my 3 over 2. Similarly, you can compute the remaining values and you can get these answers here. Clearly say the Zj minus Cj are my positive. So that means the optimal solution reached. My target is to find x1, x2, x3. So x1, there is no x1. This is 0. x2, answer is 1, 0, 0. x3 is my 230 and your maximization of Z is my 1850. Make sure student x1 is not present in the final table, so that's why answer is 0. Dear student, kindly like and comment on this video as well. Solve the following problem again by simplex method. Yes, because all are my less than signs, so we can apply the simplex method. But since my problem is minimization, so I can write this problem into the maximization. Firstly, I can multiply this by the negative sign. Fine. And then we can write in the standard form. So I can add the slack variables s1, s2 and s3. Again, you can solve the same problem with the help of the graphical method as well. But I can try to explain this lecture is the simplex method. So what are the, how many variables you have? x1, x2, s1, s2, s3. So my target is to write this value. So what is the column of the x1? 5, 3, 2. So it's a 5, 3, 2 and similarly so on. Which one form the identity matrix? So s1, s2, s3 will form the identity matrix. What are the coefficient of the z1? What are the coefficients of the z? x1 is my 10. This is my 20. Rest values are my 0. So can you find the first column? 0 into 5, 0 into 3, 0 into 2 minus 10. 0 into 3 minus 0 into 6 minus 0 into 5 and so on. Fine. Now look at all those values in the Zj minus Cj which are my less than 0 and pick the largest value in the magnitude. Minus 20 is the largest value. Find the ratio which consider only for the positive terms. So the ratio is 30 divided by 3. 36 divided by 20. So the minimum value is my 4. And this is my box element. So that means x2 is my entering variable and s3 is my leaving variable. So the next table I can replace x3 with the x2. Now write the identity matrix. The first column x1, second column s2, third column x2 and the corresponding value is my 0, 0, 0. Divided this complete row by the box element. It is 2 over 5. It is 1 over 5. This is 4. Now can you complete the rest of the elements? Again, let's start with this value. Previous value is my 0. 1 is a box element. Other two values are my 20 and minus 20. Start from the box elements. 5 into 0 is 0. Minus 20, minus plus 400 divided by the box elements. This is my 80. Can you find this number? Previous value is my 30. Other element is my 20, 5 and 3. Start from the box element. 150 minus 3 into 20, 60 divided by the box element. So that is a 90 over 5. So that will be my 18. So this number is my 18. Can you find this number? 36, 20, 6, 5. So start from the box element. 36 into 5 minus 120 divided by the box element. So that will be my 180 minus 120. So that will be my 60 upon 5. This is my 12. Similarly, you can find the any other elements like here. The previous value is my minus of 10, 5, 2, minus 20. Start from the box element. It is minus 50 minus plus 40 divided by the 5. So that part is my minus 2. Fine. Similarly, you can complete the remaining elements, so you can see the rest answer. Again, look at that Zj minus Cj. You can see this is my only negative, so you can enter them. Fine. And look at the ratio. It is 18 divided by, so it's a 90 divided by 19. It is my 20. 4 divided by, so that is my 10. So clearly say this is my minimum value. Fine. So the pivot element is 19 over 5. X1 is my entering variable. S1 is my leaving variables. Again, I can write the identity matrix. S2 second column, X2 third column. The corresponding value of the Zj minus Cj is my 0. Divided the S1 row, that is divided the first row by the 19 by 5. So this is 5 over 19, 0 minus 3 over 19, and it is 90 divided by 90. Fine. And the rest of the task is similar. You can find the remaining values. For example, if you want to calculate this, previous value is my 0, this box element 2 by 5, 1. Start from the box element 0 minus 2 over 5 divided by 19 over 5. So clearly say this number is my minus 2 over 19. Similarly, you can find the remaining elements. You will get the answers. Again, you can see that Zj minus Cj all are my positive. So my answer is x1, x2, x1. So yes, this is x1, 90 upon 19, x2, 40 over 19, and maximization of the Z is 1700 divided by 19. But since my problem is given in the minimization form, so I can convert your answer from the maximization to the minimization by taking only the negative sign. Look at one more examples. Now again you can see these are the 3 variables. Again this problem is my minimization. So I can write this problem firstly in the maximization form. So maximization is minus x1 plus 3x2 minus 2x3, and I can convert into the standard form by consider the slack variables. Again, you can complete these entries. Starting values are my s1, s2, s3. What are the coefficient of the x1, x2, x3? Taken from the maximization case. Minus 1, 3, minus 1, 3, minus 2. Rest values are my 0. Fine. So 0 into 3, 0 into minus 2, 0 into minus 4, and minus 1. So minus plus 1. This is a minus 3, 2, 0, 0, 0. Then look at the value which is less than only the one value. So you can start the entering variable. Take the ratio. Now since this number is my negative, so you can skip the ratio. 12 divided by 4, 3, 10 divided by 3. So you can see this is the minimum value. No, upper value is my minimum value. Fine, this is my minimum value. So the box element is my 4. That means x1 is my entering variable. S2 is my leaving variable. You can write the identity matrix again. S1, 1, 0, 0, first column. X2, second column of the identity. S3, third column of the identity. These values are my 0. Divided this complete row by the 4. So it is minus 1 over 2, 0, 1 over 4, 3. Fine. Now the rest of the task is again similar. You can find any of the values. Say example here. Previous value is my 1. Second is a minus 3, 4, minus 2. So start with them 4. Then it is minus plus. It's a minus 6 divided by the box elements. So the answer is minus half. Can you find this number quickly? So 4 into 3, that's a 12. Minus plus again minus. So 12 minus 2 divided by 4. So 10 over 4, 5 over 2. Similarly for the third case, it is a minus of 16. Fine. and then change the sign of this. So plus 6 divided by 4. So minus 10 over 4 minus 5 over 2. Similarly, you can find the remaining entries. Now look at again in which Zj minus Cj is strictly less than 0. Only the one value we can take. This is my input. Find the ratio which has the only positive values. 10 divided by 5 by 2 is 4. 3, but this is a negative number, so you can skip that. 1 is again a negative number, you can skip that. So the minimum ratio is only 4. So that means my box element is 5 by 2. Leaving variable is s1, entering variable is my x1. So write this as identity matrix. X2 second column, S3 third column. Write all these values of the Zj minus Cj 0. Then divided this first row by 5 by 2. So this is 4 over 5. This is 2 over 5. It is my 1 over 10. And this is my 4. Fine. And then the rest of the value you can again compute it based on the shortcut tricks. Like for example, if you want to calculate here, previous value is 2. So these 4 values. So you can start from this. This is my 5 minus of this. So minus minus plus 1 divided by the box element. So that will be 6 over 5 into 2. So that part is my 12 divided by 5. Similarly for the remaining terms. Now you can see that Zj minus Cj are my positive. So therefore I can say my optimal solution is x1, x2, x3. The value of the x1 is 4. The value of the x2 is 5. There is no x3, that is my 0. So therefore maximization of the Z is my 11. But my given problem is minimization. So therefore minimization of the Z is minus 11 is my right answer of this problem. I hope you can enjoy this session as well. So these 4 questions I have given you as an exercise. You can try to solve all these problems. You can see all are my less than sign, but make sure this is the minimization, this is maximization, this is maximization and maximization. You can verify your answers with these 4 I have given. Let me know in the comment box, are you able to understand these lectures and are you able to solve these examples in a very simple manner or not. We will see the next lecture very soon on the next topic of the LPP. Till then, you can simply share this video with your friends. Don't forget to like and subscribe my YouTube channel. Best of luck, students. Happy learning.